Two AIs walk into a bar. The third one ducks. The developer says, you're learning. So 20 years ago, in February, the first AI completed a grand challenge, and that was the first AI was able to beat Garry Kasparov in a game of, actually several games of chess. And then just this year, Google's DeepMind AI beat a grandmaster Go player. The two challenges sound very similar. They're both 2D board games, both an artificial intelligence being pitted against a globally recognized grandmaster human at the game. One of the big differences is that 20 years ago, when IBM built Deep Blue, the machine and the software that beat Garry Kasparov, that system was not extendable. It could play chess, but it couldn't really do anything else. This year, when Google's DeepMind won the game of Go, the biggest change is that system is easily extendable and easily trainable to solve other challenges. So what we're going to talk about today is the use of machine learning, artificial intelligence platforms in games. And like many technologies, the games industry tends to adopt AI and 3D and social media marketing, as we just heard, earlier than many other industries. But let's take a quick step and make sure we're all on the same page. What is artificial intelligence? Artificial intelligence, or machine learning, is a software platform, software system, that you don't explicitly program. So for developers, this is quite a big change. You train a machine learning platform. You test a machine learning platform. You give it data, and it learns and changes its behavior. You don't explicitly program it. And it's a very different way of developing software systems. Machine learning is being used in a number of different industries. After IBM executed our grand challenge and our AI, Watson, beat Ken Jennings on Jeopardy, we went on to then apply our machine learning platform to fields such as cancer research and financial industry problems. So today's machine learning platforms are being used in many industries, fixing and detecting oil pipeline leaks, curing cancer, being used by the legal industry to understand potential cases and potential problems with litigation. But what we're here to talk about today are three companies, three particular instances of how machine learning platforms are being used in the games industry. One of the biggest challenges in the games industry, and one we just heard in the last session, engaging players, converting players. So earlier this year, we engaged with a company called Sparkplug Games. They're the developer of casual games, and we're working on trying to understand, can a machine learning platform, specifically IBM's Watson, be used to actually tailor content for an individual player, and can that actually increase engagement and increase enjoyment of games? Sparkplug Games, and specifically John O'Neill, the CEO of Sparkplug Games, has developed this puzzle game, Flight of the Zombie, a classic puzzle game that is made up of experiences, levels that are 30, 60, 90-second long experiences. Each level is designed by a level designer. Each level has its own difficulty in relation to all the other levels. And the game designer of the game has created an experience curve. So the game doesn't just get steadily harder. It'll give you a couple of hard levels and a couple of easy levels to try and create a varied experience that will be more engaging than just a linear difficulty projection. So what we did with Watson, IBM's machine learning platform, and what Sparkplug did was collect telemetry from the players, how fast they're going through the levels, how many times they retry, and they're taking the data that is the seeded difficulty level of each of these levels in the game, and they added a little bit of code to their game. So this is Unity code. So where the original game would make a decision or just pick up the next level in the chain, they added 20 lines of code. And that 20 lines of code actually sent the telemetry up to the AI running in the cloud. And that telemetry was, again, player behavior data. And again, 20 lines of code made the call, sent the player data, and also received information from the AI. In this case, this AI is running an algorithm that will take a set of data and do something called trade-off analytics. Take a set of potential next moves and compare that with how the player is behaving, and determine which of the next 150, 200 levels should I give to the player next for them to be interested. So maybe this is a player that's having a really hard time with the game mechanics, so I want to give them easier levels. Or maybe this is a player that really got the game mechanic and is flying through levels and not being really challenged, so the next level I want to give them is one of a higher difficulty. Some things we found out through this exercise. One of our early assumptions was that we'd need a lot of data from each individual player to determine if they were understanding the mechanic, and we'd need to give the machine learning platform a lot of data in order for it to make a really good decision, to have it make a good choice. It turns out that, like many puzzle games, this puzzle game has 3 tutorial levels and then a couple of simple levels that everybody gets in that particular order. What we found was that the machine learning platform was able to determine, just after 5 sets of data, 5 elements of telemetry, that the AI was able to make a really good choice and start giving players content that matched their skill level and also matched the engagement pattern. Once we were able to prove that this worked, prove that it would actually engage with players, some things became patently obvious. What if we took all of the telemetry from the entire player community and used that to validate our game design? Use that to validate the difficulty of each of the levels, validate that seeded difficulty that the level designer gave to each level. We could then take all of the telemetry, all of the player interactions from this game and validate our own game design, validate that progression curve that the game designer created. Was that progression curve actually leading to player retention? Was that progression curve misformed in some areas? Was there fall off? Was there early fall off, late fall off? We can have the entire player community actually validate our game design and change the game design just by playing the game and just by keeping on playing the game. So another challenge in the games industry is creating art. And even for mobile games, even for canvas games, the amount of content and the quality of content being demanded by the industry, by competitors, and by the player community is increasing. This means increased cost, this means increased time to market, increased risk. We have a partner of ours by the name of Artomatics that is using NVIDIA chips in the cloud to take materials that you would create and that you would use for backgrounds, and the power of machine learning algorithms to dramatically increase not only the quality of content that you can create, but also increase the quantity of content that you can create. So from this simple texture that has a height map, bump map, UV, using the power of a machine learning platform that can not only manage data and make decisions based on data, but a machine learning platform can also make decisions on what algorithm to use and what variations of algorithms to use in a given situation. And Artomatics has done this so that you can take a single patch and it can automatically determine which type of, say, Kirlian noise you would want to apply to be able to take a patch and make a really believable and beautiful background. This is a great example of, stony floor, where you create just one patch and have the machine learning platform actually distribute that patch and spread it over a large area in a way where humans can't tell there are seams, and in a way that is actually aesthetically pleasing. And this next one is a great example of a desert scene. So the artist here has created two patches and spread them out over a 3D map of a rolling desert. And what the Artomatics algorithm will do is in this case, detect seams, smooth them out, and allow an artist to create a truly immersive and beautiful environment with just a little bit of work, spending a lot of time on one or two patches and then letting the machine do what machines do really well, detect edges, do smoothing, and this is all done up in the cloud with an interactive tool in a short period of time. So whereas it may have taken hours or days for an artist to create this type of background, this type of environment in the past, it can now be done in a matter of minutes. Switching gears quite dramatically here, another grand challenge that we've been engaged in is, in many games, there is the need or the desire to be able to interact with a fictional character. So being able to interact with an NPC. But current mechanisms for interacting with NPCs are fairly static. The choose-your-own-adventure style decision tree dialogues. We were working with a company and particularly an individual by the name of Guy Gandy who wanted to create an experience where you really were interacting with a true fictional personality that had a backstory and an attitude. And the game is called The Suspect, and the QR code on the previous slide and the presentation that'll be available after this has the links. But this is a classic police procedural. Somebody walks into a police station and they're very suspicious. The police put this guy into a interrogation cell, and then you're brought in and it's your job to find out what happened. Is this guy lying? What's going on? There are other people involved in the story, and it's your job to find out, are these people alive? Are they dead? Is this a hoax? What's going on? And your interface is just one where you're asking questions, much like any open world RPG, only without a linear interaction, without a linear interface. The goal, as Guy Gadney says, is he wanted to be able to throw everything at an interaction. So for this game, it included not only a conversational interface that they spent over a year crafting, it also included live video and a second screen experience. And the live video included infrared visuals of this particular character talking. And again, you're not prompted, you're not guided. All you have is a blank text input window because this character will only talk to somebody that's given them written questions. Oh, and if you ask the same question twice, the character shuts down and will stop answering you. Or if you ask for the same piece of data, same piece of information twice, even phrased differently, you'll get the same behavior from this character. They were able to build up this character not only with prose and Q&A, but also with a mind map that they had developed of describing how this character thought, what his needs were, what his hierarchy of needs were, what his favorite colors were. They added, frequently asked questions, the core elements of what you were trying to get out of the character, but they also added a very deep backstory, where he grew up, what type of parents he had, what his favorite colors had. And they were able to create a system, again, not by explicit programming, but by hiring a technical writer and a prose writer and working with other game designers to create a mind map of this character, to actually create something that not only passes the Turing test for most people, but will actually engage you and really want you, push you to come back to engage with this character. Guy, when we were working with Guy, he's worked on a number of conversational interfaces, and one of the things that we have found out from conversational interfaces is their tremendous impact and their tremendous ability to engage, maintain engagement, and increase audience participation. So there's another case study of a conversational interface, an AI, a machine learning platform that understands natural language, that's been programmed to behave like a particular personality, being associated with a telenovela. So they put up a conversational interface in the off-season of this telenovela. And not only were they able to maintain audience, they were actually able to grow audience in the off-season. And again, these case studies are really interesting, and if you're at all involved with an IP or a television studio or a movie studio where you're creating a secondary experience for a property in another medium, I strongly suggest looking at creating a conversational interface and putting enough effort into it to give it a personality, and a personality that's either core to that property or in a side story of that property. It can really drive engagement and really do you and your customer a lot of good. So I've gone through 3 case studies and I went through them really quick. Thank you for being patient. There are a lot more. AlphaGo is a use of an AI in a game to train people again, how to deal with cyber attacks. Guy Gandy, who I mentioned repeatedly, has written an excellent article on how to get to next on conversational interfaces. And again, Artomatics, go check them out. The link's right there, and the link will be on the presentation that's available for download at the Casual Connect site. And with that, thank you very much, and hope to see you soon.
Awesome. Do you have time for some questions?
Yep.
What's a good path for getting into machine learning?
Couple good paths. Google has done a lot to create some simple tutorials. The link is up here. They've got a set of videos that introduce the topic, and then from IBM, if you Google Watson Developer Cloud. We have a number of our AI APIs that are freely available. We also have an SDK plugin for Unity, so you can make calls into Watson, like the code I just showed, right out of the Unity SDK. We're working with other platforms as we speak. And so those are great ways to get started.
Thank you very much.
Hi. Do you have any advice for identifying the right kind of problem to apply machine learning to? Like how do you find nails for this shiny new hammer?
That is an excellent question. Some of the guiding principles for the right kind of problem for machine learning, lots of data is a good one. If you are collecting telemetry from players and you want to do something with that telemetry, that is a great, that's a great use case. Anywhere, like with the Artomatics example, where you want to do something replicatable, but you want it altered. So you want to paint or shade a room, or you want to take a massive amount of data and you want to determine how best to apply. All of that data represents input or tests that have been passed or failed, and then you want to apply that to a particular problem. Trade-offs. How do I make a decision? And I've got just a tremendous amount of information. Trade-off analytics is one of our APIs. Anything that deals with human language, so eye movement, eye tracking, or just text input or voice input, those are ideal use cases for machine learning platforms at this stage of technology. So conversational interfaces.
Cool. Well, George, thanks a lot.
Thank you.
Very interesting stuff.
Enjoy the rest of Casual Connect.